Okay, so continuing on, just getting a bunch of simple instructions out the way. This time I'll be looking at some flag instructions. So we'll start with something like CLC. So let's just go look for CLC. So this one is clear carry flag. And this one is F8 as zero operand. We'll also do CMC, complement carry flag. This one being F5. And then I think that there's also STC. So this one is set carry flag, which is F9. Then we'll move on to LAHF. So let's see, where's that? That's up here. This one is load status flags into AH register. And this one is 9F. There's also the S version of this, which is to store. So that one is here. So this one's 9E. Then we'll do push and pop for the flags register. So let's just do push first. So push is push E flags register onto the stack. This one has a few different versions of it, which are, there's this sort of like generic push F1, then D, then Q. This one says 16 bits, and this one says E flags and R flags. If you actually encode this with NASM, then obviously they're all the same as each other. So this is really just depending on which mode you're running in. So I'll only do push F here. So we've got push F, and then we'll also have pop F. So this one here is 9C. And then the pop version of this is up here, which is 9D. Okay, so that's push and pop for flags. After that, I think we'll move on to int3, or like the int instructions. So there's up here, we've got int3, int n, int, this is int o, not int 0. And then this is int 1. So all of these are zero operand except for the int with the 8-bit immediate. So we'll just do all of these in order of int o. Then we've got int 1, int 3, and then there's int something, so we'll do OX7F as I usually do for these sorts of things. So this int 3 is CC. Int n is CD with some byte. So this one is actually opni for this particular one. Int I is F1, and then int O is CE. Then there are some UD instructions. So these are for generating an undefined instruction or an invalid opcode exception. So let's just copy these ones. We've got RM for these first two. So we've got UD0. UD0 with R and then RM. So we'll just say, for example, ECX and then, EDX or something. And this one can be RDX in here. Same thing for UD1. And then UD2 and UDB are just sort of standalone instructions here. So we've got UD2 and UDB. So these ones are D6, 0F, 0B. And then here we've got 0F8, 9. This is RM for these two. And then these ones are 0F, FF. Oh, sorry, that's not 8, 9, that's B9. And then these ones are also RM. So after UD, I think that I've already got read timestamp counter, so I just want to fill in read timestamp counter P. So this is read timestamp counter and processor ID. So this one's a zero operand again. Let's just go and put this one down here with this. Then we'll also do XGETBV. Let's put this one here. So XGETBV. And then we may as well pair that up with SETBV as well. Okay, and then after this, we'll do some random instructions. So this will, literally rand and seed. So we'll start with seed here, maybe. So these ones have operand encoding of M, but they're only actually register matches, and they're all opcode extension 7 here. Okay, so let's do read random seed. So we've got word, double word, and keyword here. So let's just do CX, EX, and RCX. And we'll just take this one for all of them. So this is actually op-n M, but really this is it's only matching on reg. And then we'll do the same thing for rand as well, which is the same operand encoding and everything, but this time it's with opcode extension 6. Okay, so those are some random ones. Then we'll do, we've got, for example, RET and syscall and stuff, but we don't have SYSRET, so I'll just add that for sort of completeness at this point. So we've got SYSRET here, which is OF07. Put this down with syscall. Then we will need to do, okay, let's just do rex plus maybe for this one in the comments here. There's also IRET, so I'll add that as well. IRET. This one again has a couple of versions of it, D and Q, but really I'll just need to support this one because they will just get output as the same thing anyway. We'll just say CF for this. Then there's a couple of sort of stack related ones, not necessarily used really, but these ones at least will be useful for testing like multiple immediates here. So we've got enter. These are split up into different forms here with like a hard-coded 0 and 1, but really they're all actually just encoded in the same way. So this is actually just like a single form here. And this has a new operand encoding II because there are two immediates, and it's always a 16-bit and then 8-bit in this case. So I'll copy this one as the opcode. So this is enter. And for this one, we'll do, let's just say we'll do OX7FFF because this one's a 16-bit. And then for the second one, we'll do 0, 1, and 2, let's say. Or 0, 1, and 7F. And this one will be a new op-n of II. Then we also have leave, which pairs up with enter, and these ones are all the same. These are just C9, so we'll just do leave as one thing. So this one being C9. I think that's enough instructions for this recording, so we'll just take all of these. Bring them over to the encoder test. So most of the tests are actually going to be at the top here, above the MOV string ones. These RET ones, actually all of these ones down here, close to the syscall. Then we've got them split up in this way. So we've got the interrupts, we've got the undefined stuff, or the invalid opcode stuff. Random stuff, these ones are not actually part of the tests here. These ones are just notes. And then this one can go down with the read timestamp counter. Read timestamp counter. This one will go down here. So let's just get all of these mnemonics. And put them in the tests. We'll go and add, let's just add them around here. These ones can go down with syscall like I did before. We'll just split these up a little bit. We'll put this one up here. Split these up a little bit here. And we will just get rid of any duplicates as well. Okay. So let's go and create some empty form tables for these. We'll just copy these ones to above syscall. Then we've got SYSRET and IRET can join this group down here. Okay, so let's go back to the encoder tests. So basically these ones here are 0, NA, 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 NA. Same for a lot of these, actually. These ones are all zero operand by the looks of it. Let's just take these ones. Then this one we've got just a single operand. So this is a byte. And we want to take one thing here, which I think I probably set as a 7F, NA, NA, NA. So here we have UD0. Let me just go look at the forms for these again. Yeah, so this was just 32. So these ones can be D word with CX and then DX, NA, NA. But these two, this one and this one, need to be memory access. These two here are just the zero operand versions again. Same goes for these ones. And then these random ones here. So for this one, we've got word, D word, and Q word. And then in this case, we've just got CX for all of them. So the last ones are down here. So let's do RDTSCP. This one will just be zero operand as well. Then LAHF is also zero operand. SYSRET is zero operand, and IRET is zero operand. Enter here. These ones are going to be. I wonder what to set the width for these ones as, because they don't really have, like, you know, a specific width that makes sense, I don't think. So maybe I'll just set these to 0 for now. And we'll do I as 7FFF. Then we've got I as OX00, 1 and 7F. And then we've got two NAs here. Okay, so let's take all of these over to the forms. We'll put them above here. This is where the bulk of them is, or the bulk of them are. Okay, let's just try and generate. Okay, that all seems okay. Instruction not supported in 64-bit mode. Line 13. Okay, yes, we don't need to do that one. Let's just get rid of that. Okay. Regenerate. Okay, that all seems okay now. So let's just run the tests. And now we get the form couldn't match panic. So let's just start creating these forms. So basically, all of these ones here are zero operand. So this is down to int 3. So these will all match on 0. The op n will be ZO, and then the opcode for this will be, I've got too many somewhere here. I've still got this in this list here. Okay, let's go down to int 3 again. We'll find opcode and just put all of these in here. So that should cover these ones. But then int needs to match on This is specifically bytes. So this will be bytes where op_n is, I think this was m. Oh no, it's I. But op1 here has to be an 8-bit immediate. So the opcode for this one is CD. Okay, so now UD, let's just remove these duplicates here. UD is going to match on width of, this is UD0 is going to match on width of D word. We're going to do op_n here is op_n rm. Op1 can be reg, op2 can be reg or memory. Then we've got a map, so map is 0f. Then the opcode itself for this one is oxff. And then we've got a similar thing for UD1, but this is B9 instead. And all of these actually need extra curly braces in here. Let's just go and add those. So that's those two done. Then UD2 is the same, but the opcode is 0b, and instead of having any operands, this is now ZO again. So we'll take out these operand matches. And because this is ZO, we'll do width is just matching on 0 in this case. Then we've got UDB, which is the same thing, but with no map, and the opcode is D6. Okay, so that's those ones. Now the get and set BV ones are basically the same as each other. So, you know, again, we've got width is 0, op_n is op_n ZO. We've got a map for these ones. We've got opcode is 0, 1, but this time we have a fixed mod rm of D0 and D1. These ones are the same as each other here. So this one is the random stuff. So RDSEED and RDRAND. This is going to be width is width for this is word or D word or Q word. Op_n for this is op_n_m because it's using the rm field for the encoding, but the op1 should only match for reg. Then we've got the map is map 0f, followed by the opcode, which is C7, followed by opcode extension. In the seed case, it's 7, and then in the RAND case, it's 6. So then we've got enter and leave here. So they are all the same encoding. So we need a new op_n for this one. So I'm saying that this is going to match on width 0 because there's not really a specific one here. I suppose I could match on 0 word or byte, I suppose, but maybe I'll just leave it as 0 for now. So op_n here is this new op_n_ii, so I need to output a second immediate for this as well. And for this we just have opcode as, so we've got op1 is an immediate 16, op2 is an immediate 8, and then the opcode is C8. Leave is just a zero-operand. And the opcode for this is C9. Then we've got SYSRET. So SYSRET down here, well, both of these are going to match on width of 0. They're both opn zo, and then they've both got some opcode of something. In the case of SYSRET, we've got a map as well. So this is map 0f, and the opcode for this one is 07. The opcode for this one is CF. And then finally we have read timestamp counter. This one has the map of 0f, opcode is 01, followed by a fixed mod RM, in this case of F9. Okay, so let's just run these tests. Okay, I need opn I. Okay, so we get unsupported operand encoding for enter, which is expected. So we'll go to the encoder. So this is where we're switching on the opn, and in this case, this is basically like it's zero-operand. So in this case, I want to just do nothing for this thing. And I think it's already outputting. Okay, so I'm getting slightly incorrect things here. This is probably because mod RM, I need to tell it that there's no mod RM in this case. Okay, and now we're getting the incorrect IRET value. So for IRET here, let's just go and look at the form again. So we've got IRET. I mean, all of these are valid encodings on 64-bit. Perhaps I should just match on the size for this one. So, for example, keyword. Oh, maybe 0 is okay. I think 0 is okay. I'll just tell it to do enc width of keyword for now. So we'll say the encoding width for this is keyword. And I can change that later if it causes problems. Okay, so that's just a few more simple instructions out the way, and I guess in this time I've actually added a new operand encoding for 2 immediates, even if it's only for 1 instruction right now.